Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
What is Docker? So guys, when we say, all of us, like when we discuss about Docker technology, then we say Docker is a container management tool. Now, what is the definition of tool? So now when you say that what is the definition of tool, that means usually we use the different tools. Now typically we use for the saving cost, saving time, correct, and improving the efficiency, like cost, improving the quality. Okay, so this is the reason we use a different tool for over the period of time, right? Now the question is, okay, so Docker is also on a tool which will save cost, save time, and improving the quality. But for what? So this is what we have come to: run apps in data center. Okay, so tool, Docker is a kind of tool which will save cost, save time, and improve the quality of the software to run apps in a data center. But the question remains same: what is container? Because if you cannot understand the Docker, if you are not able to understand the container. Now the question is, what is container? What is container? That's the most important question, because Docker is doing nothing but managing the container. So what is container? Because if you don't know the container, then you will not be able to come to know how this particular tool, which is saving your cost, time, and improving the quality of the software. So now we need to understand what is container. Okay, so now guys, for time being, I would request you all to forget about the Docker and forget about the container. Just let's focus on one of the question, and that question is, what are the components needed to run any application aka software? That's all. What are the components? What are the components we need to run any applications aka software? You've been running software from last so many years, 30 years actually, right? So what are the components we need to run any applications? So now if I look at this, typically what are the components we needed? So let's draw some pictures here. Here if you look at this, we need first and foremost basic thing, and that is hardware, correct? This is the hardware we need for components. And then hardware includes CPU, RAM, storage, and stuff like that. On top of, we have what? We have operating system, correct? Now, once we have operating system, what we do, we log in as a, let's say my name is Rajesh, so I log in as a Rajesh here. So this is a Rajesh user ID. And then I log in, I create applications, I run applications. Okay, so this is the user space of Rajesh, and then you run applications. Have you run any application without user? No. We have run Jenkins using Jenkins user, Apache as Apache user, Tomcat as a Tomcat user. I mean, we need one user to run any applications. How many applications I am running right now, you know? Let me show you. Go to the task manager. Okay, and see here. Go to the details. Look at this. Here, Rajesh starting from here to here. Okay. Now these other applications, these all are applications running by the system user. Okay. And here there's some local service user. So different user names are needed to run applications, correct? These are the applications. So now if you look at this here, you need a hardware, then on top of that operating system. And operating system, you logged in as a user and you run applications. Guys, you know that this application needs CPU allocation and RAM allocation, correct? So have you ever thought about it, how this user layer is being created? This is user 1. In one machine, you can create a more user, 2 user, 3 user. For time being, I created 3 users. How many users you can create? Do you know? I don't know. Do you know how many users you can create? We don't know, right? So the number of users you create, and each user can run their own applications, correct? Own applications. So have you ever thought how these applications, how this user's layer is being created? See guys, if you're a normal user, this you cannot go. You cannot go. If you're a normal user, this you cannot go, correct, right? You cannot log in and check the each other user space, correct now? So how this user space is being created? How? Anyone has idea?
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Anyone has idea?
No worries.
Okay, no problem. So guys, understand that we have a hardware. When I say hardware, we know that very well, so I don't need to teach you. Then we have operating system. Now operating system, when we call it, is like a huge word actually. Operating system has so many things. But you know one thing, who's helping you to interact hardware and human input and output? Who's interacting? So in operating system, you have a kernel, correct? Correct. Now kernel has many things. Kernel has namespaces. Okay. Now the question is, what is namespaces? So guys, namespaces, see, in a simple way, I'll say kernel is nothing but, just let's find it out. You only find out yourself. See what is a kernel. See here, this is a kernel definition. Okay, and kernel is what? See here, read this. Read this. This is kernel. Kernel is a computer program. Simple. So guys, it's a program. So kernel, so operating system has kernel. Kernel has a program. Now these programs, we call it namespace. Okay. In simple way, I'm just trying to explain. You will have a time. You can research more about the kernels, but in short, the question was, what are the components needed to run any application aka software? So we need hardware, then we need a operating system. Operating system has kernel, and kernel has namespaces. So the question again was, in this image, who's initializing user namespace, user space? Who's initializing? So you know one thing, this user. Okay, let me write it in a little bit with a space. Okay. Okay. So here namespace, who's creating this user user space? So this user space is creating through the user namespace. Yeah, there is one program, we call it user namespace. This is creating the user namespace. Now the question is, how many is allowed in operating system? How many you create? Okay, how many allowed? How many allowed? How many users you can create? And how many need? Now when I say need, remember this is for applications. How many allowed, how many need, and how many can get created? Can get created. Can get created. So guys, how many user namespace you create is allowed? So multiple. Think about it. You can create multiple user namespace. Means you can create multiple user namespace. Now that is been created from where? User namespace. Where it is? Namespace. Okay. And that namespace is in kernel. Think about it. Kernel is an operating system. So how many allowed? Multiple. For running in one application, how many need? One. Can get created. How many created? Here, this is a multiple. Is, allowed also multiple. Can get created multiple also. So same way, so this is the done. So how this user space something sort of this is being created is coming from the user. Now where it is? Operating system has kernel has user namespace, and that empower this. Let me change the color. That empower this. So guys, did you understand that so far? Each one of you? Yeah. Now guys, see here, this each user is running something. When I say something, means anything which each user run, it run applications. So guys, application needs CPU and RAM. That is how it is running. If it is not getting the CPU and RAM, then how it will run? Simple logic. Guys, have you ever thought about it? Who is giving the CPU and RAM to the each processes of the particular operating system? Who's giving? Have you thought about it, from where it is coming? I don't know, but let me share with you. All the CPU allocation and RAM allocation come from C groups. Okay, now you can understand C groups little bit later in detail. What is C groups at a high level? See here. Okay, see here.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
C groups. Okay, so just simple definition, C groups. Okay, you can read more about it. I'm not teaching you in detail about the kernel, but I just want this to be answered. That's all. So guys, C groups, who's responsible for allocating the CPU, memory, disk, network to the processes. Okay, processes. Now the question is, how these C groups will manage the CPU and RAM allocation? Because in the system you have so many processes, right? So how do you do that? So guys, you see here, look at this Windows itself. See here, C groups is in kernel, and now they are giving you. Let me just get some screen here, so I can draw. See here, this is one process. This is one application, okay, and this is run by this username. I don't know who's this user. Okay, now this user is getting this much of CPU and this much of RAM. Okay, you see that. But how this are they giving the CPU and RAM allocating to this process? No, actually, they need to monitor how much this CPU have consumed, how much they are consuming, and RAM and stuff like that. So what happen? Each processes get one PID number, and that's a unique number actually. Okay, this is a PID number. So what happened? This CPU allocation happened to this PID. Okay, and then memory allocation happened to the PID. I mean, they are using this application associated with this PID, and by looking at the PID, you can find out, okay, how much CPU and how much RAM this process ID is executing. That is how. So C groups is allocating CPU and RAM for the PID, each PID, and this PID is very unique in your operating system. Okay, so now always when you start the PID table, you start with like this. Let's say 0, and this is a 1. This is your kernel, okay? And then you log into, let's say, Rajesh, so you will become a 4 process, and let's say someone else log in 5, okay? Now here, this user is running some other application, so it may become 6 other applications, so this may 7. So this is called PID table, okay, process table, okay? That is how it's been designed. Okay, so now how this C groups is allocating the CPU and RAM hardware to the each processes. How? So that is where you need to create one PID table mapping. So here you need PID table. So let me draw a picture first. Okay, think about it. So here this user is being created by user's namespace. But you know, each user of your operating system get one PID table, that is shared table. Understand that. This PID1, PID namespace, this PID allocation is shared between this user also, or any other user also. Okay, and that is how you get a 0, 1, 2, 3, 4, 5, 6. That's a process ID and also. Okay, so now who's creating this PID table? How this PID table is creating? So C groups will allocate the CPU and RAM for this application which is run by this particular user. So that PID is created by PID namespace. Okay, how many allowed? When I say allowed in operating system, okay, allowed in OS, I'll just write it is so you'll understand that. So to run any application, how many PID is allowed in operating system? Only one. Okay, see, user can be created multiple, but PID table you get it only one. See here, and this PID table is shared by everyone. You see here, you can look at this task manager. This PID table, you see no duplicate entries are there. You see that. Okay, so see here, start with a 0 and then followed by dub. So this is how it is. Okay, so now this is the thing. So now this how this PID getting initialized. So PID get initialized from one of the kind of namespace which is called PID namespace. Now how many allowed in the operating system? One. How many need for applications? Only one. And how can you create it? Multiple you can create it. But how many allowed? Only one. So understand this way. Need one. Okay. Now guys, see here. So what you get? You get the PID table and you get the user's namespace. Now you are running application. This application need file system. File system means what? File system means this application need a file system means C drive, D drive, or something like that. Okay, file system. We call it a mount. Okay. So before that, I would like to give you a little bit of introduction about the file system. I don't know how many of you know that. So I'll be a little bit safer. So you will understand better way. So file system. You know, what is a file system first? So in short, I will tell you, file system is a collection of files and directories, simple, for specific purpose. Okay. Now, this is a file system. Now, there are types of file system nowadays you see in your regular day-to-day activities. One of the file system, which we call it, is a boot file system. Okay, boot file system. I don't know how many of you have heard about it. Boot file system. Okay. Now another file system we call it a root file system. Another file system we call it a user file system. Another file system we call it app file system. Okay. Now what is a boot file system? So guys, these are the file system. This boot file system you can say is kernel. This is the boot file system. Now when you try to log in this file system, which is collections of files and directory, during the runtime in operating system, you'll not be able to do that. Okay, so it's loaded in the RAM. That's called kernel. Okay, 50 to 100 MB of data is getting loaded in RAM, and that's how the operating system works. Now, what is a root file system? Let me show you, which you can see and which you are seeing every day actually. Let me show you. Root file system. I just put it in Google.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
And see, have you seen this root file system? Have you seen this kind of file system anywhere? Guys? Have you seen this? Have you seen this? Unix. Yeah, this is Unix. Let me show you the Windows also, so you'll get comfortable. So let me show you the Windows. Windows root file system. Go to the My PC. Guys, this is the root file system, especially C drive, okay? Now, inside the C drive, if I go, I see program files, program data, users, Windows. These are the root file system, okay? So root file system, which is mounted, read my line, okay, what I'm saying. Root file system is mounted at the root, and which you can see it. Root means my computer is a root for Windows. / is a root for Linux. So root file system is mounted at the root, and whatever you see, that's a root file system. Okay. So guys, now this is your root file system. Now what is a user file system? So when you go inside the user space, let me go to user space, and then you see that. See, I'm going to the users and Rajesh user. And Rajesh, this is the file system. Whatever you can see, this belongs to the user file system. See, every user has their own file system. Every user will have a desktop. Every user will have documents. Every user has a download and stuff like that. So this is called root file system, user file system. Okay, guys, you are getting my points, right? These are the file system.
Yes, sir.
Yeah. Now, last file system is application file system. You know, I think application file system I'll show you directly, so you'll understand this. See, typically what I do, every tools which I install in my Windows, I install in the tools location. In the Linux, when I install my tools, I install in the OPT directory. That's my habit. So now you see there's so many applications I have installed. Now, which application we would like to see? Let's say SonarQube. SonarQube is one application. So this is a this one. So this is one application. Whatever you are seeing here, files and directories, this is the application file system. Do you know one thing? The repository which you are accessing every day, Git repository, you must be working. That is also one file system. That has a files and directory. For what purpose? For storing your product code. So that is also one file system. Git file system we call it. Git repo file system. So guys, this is the short information about the file system. Now coming back to the question here, each user to run application. See, again, I would request you all to read this question. What are the components needed to run any application aka software? So here you need an operating system. Operating system has kernel. Kernel has a namespaces. Namespaces, I need a user namespaces, and I need a PID. User namespaces. Using that you can create one user, multiple user. But you need a PID also, process ID table. So here this you all user get only one PID. One PID is a shared PID table. Okay, now the question is, this user can be created from where? This user can be created from where? So user namespace. Where? PID can be created from where? PID namespace. So same way guys, each user need a mount. Yeah, each user need a mount. Which mount? So they need all these 4 mount. This is a system mount file system. System, okay? This is a system file system. Okay? Mount. They need a boot system. They need a root file system. And then they can run application, and they need a user file system also. And then finally application. This is your application. Here, the one which I am saying, run any app aka software. This is where it is, this one. So guys, app need root. Think about it. See here. See, think about it. I install the application SonarQube. Where? C drive. C drive is what? Root. Tools is what? Under the root. So guys, any app, think about it, any app need a root. Root can be only initialized when you have a boot, and that is a boot your kernel, and this is what you see in the operating system. Okay, now for any user, without user you cannot run an application, so user also has a user file system. So guys, the question is, for any application to run, you need a mount. Okay, MNT, mount. Okay, now mount can be created from where, which namespace? In the kernel, mount, you have a mount, right? So mount can be created using which namespace? Mount means root file system. Root file system. So guys, mount can be initialized by the mount namespace, MNT namespace. Okay, there is a one kind of namespace which you have. Now guys, how many allowed in one operating system? How many root file system you can create? I'll put it in a simple way. Okay, how many C drive you can create in one operating system?
Only one.
Only one. So how many mount is allowed in one operating system? One. How many need for application? One. But how can you create multiple? You can create multiple, but we are not creating it. Okay, we are creating only one C drive, but we can create a multiple C drive also. Okay, so user will log in and see here. So here, if I look at the image now, if I look at the image, so this mount, whatever you see, this mount is also shared mount. So here there's one mount created, this MNT, this is MNT namespace coming from the MNT namespace. This is also coming from here. So this is the one which is also shared one, guys. Okay, so you got the PID, you got the MNT, you got the user. This application is running. Now guys, this application need to be accessible from outside. Outside means, see, in my laptop it's running, but that application need to be accessible from outside. Now how can we access this from outside? Any idea? How can we access this application from outside typically?
Network.
Network. So guys, in each operating system you get initialized one network. Okay, so this network also is just shared between all the users. It's not like, okay, each user will get their own network. Not like that. This network will be created and shared by all the users here. All the users. Okay, now you must be wondering how this network is getting initialized in the operating system. So guys, there's one more namespace for that, and that is called network namespace. Okay, network namespace, and that is how many allowed is one. How many need for the application? Only one. And how many can be created? Multiple. Think about it. So here, ultimately what I was trying to teach you, what are the components needed to run any application aka software? So you need operating system. Operating system has kernel. Kernel has a namespaces. Now each of these namespaces we need to run application. So in a simple way, for running this application, you need a one user space. You need one mount, one PID table, so you can get a CPU and RAM, and you get a one network. Now, how many allowed, how many need, how many can you create it? I told about it. C groups, which is I have already explained it to you. No, now this user which you create, this user or this user, whether this user is a normal user and a root or a root user. Who's that? Whether this user is normal user and root user. So guys, this user is your normal user or root user that you understand from the one component in the kernel, and that is called capabilities. Okay, now capabilities. This is a component which decide whether this particular user is a root user or a non-root user. Because if it is a root user or an administrator user, he'll get a more access to the kernel. If it is a normal user in the system, then he will get a lesser access in the system. Okay, so now this is decided by capability. So overall, if I understand, guys, what are the components needed to run any application aka software? So you need, these are the namespaces, you need a C groups and capability. Can we look at it in the image? So that way it will be locked down in our memory. Look at this here, guys.
Thanks for watching. Want to study further? Join our training programs today.